Today we'll begin section 2.2, and what I want you to think about is look at this getting ready box. If you worked in construction and let's say you had to build a roof, here's a sample piece of the roof, and we have to build these vertical posts in the diagram. And we can figure out what the height of each of the posts are going to be by using direct variation. So what we're going to look at is writing and interpreting direct variation equations. So a direct variation equation looks like this. Y equals kx, or if you were to solve for k, y over x equals k. And this is saying that x and y are directly related. And they relate by the same value or constant k. And we call that k the constant of variation. So let's record these equations and try problem 1. Now that you're in your example packet, go ahead and write the direct variation equations next to problem 1. Direct variation is y equals k times x. Remember, k is going to be a number in a second. Or that number k, or the constant variation, equals y over x. So in problem 1, we're looking at two tables, and we want to know if y varies directly with x. If so, let's find that constant of variation and the actual function rule. So for y to vary directly with x, the constant will always be the same. The k value will always be the same. And since k equals y divided by x, that's what we're going to try. So in example A, let's figure out y divided by x. So here we have 2 divided by 1, which would equal 2. So k would be 2 in this first line. Let's look at the next line. 6 divided by 3, which is also 2. That's good. And the third line, we have 8 divided by 4, because we're doing y divided by x, and that also equals 2. So because we got 2 every time, that means, yes, it's direct variation, k will equal 2. So my function rule will be y equals 2x. Let's try example B. If the k is always the same, we know it's direct variation. To find the k, let's do y divided by x. So 4 divided by 1 is 4. Let's try the second line. 8 divided by 2 is also 4. Looking good. 11 divided by 3. Is that 4? No. That means this is not direct variation because they don't always all equal 4. Now that we looked at a table of values, let's look at equations and decide if they're direct variation as well. Well, for direct variation equation, when we get y by itself, we'll have a constant number, k, times x. And that's it. There are no numbers added or subtracted. We'll just have a constant times the x. So let's get y by itself in example A. Example A, we have 3 times y. To get rid of the 3, we will divide both sides by 3. When I divide both sides by the 3, I'll get y by itself on the left side, and then I'll have 7 divided by 3, or 7/3 x. And so basically right now I have some number, 7/3, times the x. So this looks very similar to direct variation. In fact, it is direct variation. So yes, this is direct variation, where the k value in this example will be 7/3. Let's try example B. So we need to get y by itself. So right now it's being multiplied by 7, so I'm going to divide everything by 7. Because 7 divided by 7 will divide away, and I'll just have a y. I have 14 divided by 7 is 2, or 2x, and 7 divided by 7 is 1. So for it to be direct variation, it should look like y equals kx, where k would be 2, but this plus 1 is attached to the end. That makes it look not like direct variation. So this one is not direct variation because it has that plus 1 on the end.